CONVINCE is a Celtec Plus project aiming at reducing the power consumption in IP-based video distribution networks. Partners followed an end-to-end approach from the headend where the content is encoded to the terminal. Partners built an integrated demonstrator aiming at studying several use cases.
In this use case, we show how we can reduce the power consumption of videos on CDN for non-popular contents. The popularity of videos is continuously updated on a popularity server that we have here. When the set-top box asks for a video that is popular, we see the traces. This popularity server is going to forward the request to the CDN, and the CDN sends the video to the set-top box. In the other case, when the client asks for a non-popular request, the popularity server is going to proxy this request to a transcoder that is going to send the transcoded video to the set-top box.
The goal of this use case is to show that power consumption in network can be reduced by choosing each time a path that consumes less power and offers at the same time a good bandwidth for videos. Upon receiving a request from the client, the video-on-demand server starts sending video packets. If the SDN controller executes the conventional routing algorithm, it selects the shortest path. If the SDN controller executes the go-green routing algorithm, first it computes a number of candidate paths that offer a good bandwidth, then it selects among them the one with the lowest power consumption.
In this use case, we demonstrate how to improve the energy efficiency of video surveillance while keeping it at the same time more easily managed. In the baseline scenario, the camera is always on. And in our improved scenario, we add this kind of external motion sensor nodes. And the camera node here is switched on, off for the most of the time. When this intruder comes to the area, this motion sensor node wakes up the camera node, which then starts streaming to the terminal.
We have implemented a virtualized version of the surveillance camera demonstrator. In the demonstrator, we have virtualized the camera node, and we are managing it using a centralized orchestrator. The system has a small energy overhead because of virtualization, but the benefit is that the management of the system is much more easier.
Data communication over a cellular network requires much more energy than a Wi-Fi transfer. Therefore, we want to transfer as much traffic to Wi-Fi as possible. A normal situation where we have a congested Wi-Fi network, many routers competing on the same frequencies. We have built a managed Wi-Fi system where the routers sends their environmental data to a control unit. The control unit calculates the optimal configuration for each router. Here we see one of the routers just got a new configuration, and we see the congestion dramatically decrease.